There are quite some amazing materials in superhero films. Just think of vibranium, the metal you'll find in Black Panther's suit, or uru, which is the metal you find in Thor's hammers. And then there's adamantium, that's the metal grafted to Wolverine's endoskeleton. In this video, I'm going to take a look at 5 key properties of adamantium. Hi there, I'm Dr. Fitzgerald, the superhero scientist, and on this channel you'll find videos about the science and engineering of superheroes, Star Wars, and lots of other topics. If you're enjoying this video, well, please give it a thumbs up. Right, let's get into adamantium. Let's get the obvious out of the way. Adamantium is not real, it's an entirely fictional material. So please take anything I say about adamantium here with a pinch of salt. Nevertheless, that doesn't mean that we can't speculate about its properties, right? Well, that's exactly what I'm going to do here. For this video, my primary source is the Marvel films featuring Wolverine. I'm not going to talk about all the different versions or variants of adamantium that have appeared in Marvel comics. There's just too many to cover in one video. And be sure to watch until the end, where I'll give you a recommendation of a material that could be used to replicate some of the abilities and properties of adamantium in the real world. Property number 1, adamantium is an alloy. Or is it a mixture of different chemical resins? Well, either way, it means that adamantium is not a chemical element. A chemical element is a substance which is made from just one type of atom. Oxygen, which we breathe, that's an atom or a chemical element. Carbon, which you'll find in diamonds, that's a chemical element or an atom. But CO2 is not, because that is a molecule. It contains one atom of carbon and 2 atoms of oxygen. An alloy is a mixture of different metals or a metal mixed with other types of atoms. For example, iron is a metal, but it's also a chemical element. However, steel is an alloy, and that alloy contains iron as its main component, in addition to trace amounts of other elements or metals. For example, you might include carbon or nickel in steel alloys. And there are lots of different alloys out there. Titanium, for example, can be found in many different alloys, and they can be used in many different ways. For instance, you have titanium 6 aluminium 4 vanadium, which is an alloy containing 6% aluminium and 4% vanadium, and that can be used to make parts for the aerospace industry. And then there's another alloy, titanium alloy that is, titanium 6 aluminium 7 niobium, which contains 6% aluminium, 7% niobium, and can be used to make replacement parts for the body, such as replacement hip joints. So it's quite likely that adamantium is an alloy. And in that alloy you'll find known chemical elements like iron or titanium, but you'll also maybe find fictional chemical elements, the type that you'll only find in the Marvel universe. It's also possible that the adamantium mixture contains chemical resins, and these can be used to make plastics. But given how adamantium behaves and how it looks, it seems more likely that it contains more metal than chemical resins. Property number 2, adamantium is a liquid at high temperatures. In X-Men 2, we get a shot of adamantium in its liquid or molten state, boiling away and ready to be used. Now I'm going to make a prediction on its temperature and say that it probably is somewhere between 800 degrees and 1500 degrees Celsius in that molten state. To put that in perspective, some stainless steel alloys will have a melting point of 1500 degrees Celsius. That's the point at which it turns from a solid into a liquid. And the titanium alloy, titanium 6 aluminium 7 niobium, also has a melting point around 1500 degrees Celsius. Property number 3, once it cools, that is it. In X-Men 2, William Stryker mentions that you need to keep adamantium hot. Otherwise, if it cools down, it sets into a particular shape and it'll stay in that shape forever. In the real world, we do make materials that once cooled, that's it. They're going to have that shape, well, forever. One example is thermoset plastics. Thermoset plastics cannot be remodeled or reshaped to create another shape after they have cooled. Now, these materials might be very rigid and resistant to temperature, but a big problem with them is that they're not recyclable. In terms of sustainability, that's not a good thing. In the films though, when we look at adamantium, it seems like the only thing that can destroy or disturb or change the shape of adamantium is adamantium. In the film The Wolverine, we see Wolverine's adamantium claws chopped off by a very hot adamantium sword, indicating that, well, adamantium is the only thing that can destroy adamantium. Property number 4, like all materials, adamantium has a density. But what is the density of Wolverine's adamantium bone? Now, density is the amount of mass per unit volume for a particular substance, and different substances have different densities. Imagine we have a cube of water and a cube of gold. Each side of the cubes is 1 meter in length, and that means each cube has a volume of 1 meter cubed. The mass of the cube of water is 1,000 kilograms, while the mass of the cube of gold is 19,300 kilograms. So while the boxes have the same volumes, the gold cube has a larger mass than the water cube. This means that there are more atoms of gold per meter cubed than molecules of water per meter cubed. In this case, the density of gold is 19,300 kilograms per meter cubed, while the density of water is 1,000 kilograms per meter cubed. That's an explanation of what density is, but let's think about how we could calculate the density of Wolverine's adamantium bone. Now, to do this, I'm going to have to make a number of assumptions and introduce a number of different figures. So let's take a look at those figures. First off, we need to know the mass of the human skeleton, and this varies depending on height and body type. For this calculation, I'm going to assume that the mass of the human skeleton is 10 kilograms. Number 2, we need to know the density of human bone in the body. Well, fortunately, that's also known, and it's approximately 1,800 kilograms per meter cubed. Number 3, with the mass of the human skeleton and the density of bone, we can now calculate the volume of bone in the human body. We know that density is equal to mass over volume. You can rearrange that equation so it reads volume equal to mass over density. We fill in the values and we find that the volume of bone in the human body, in this case for this particular individual, is 0.0056 meter cubed. Number 4, next we need the mass of Wolverine's adamantium bone skeleton after the treatment. According to the character profile fandom website, Wolverine's mass is 135 kilograms after the treatment. But a normal person of Wolverine's height and build without the adamantium skeleton would have a mass of about 85 kilograms. So this means that the adamantium skeleton increased Wolverine's mass by 50 kilograms. As a result, his skeleton now has a mass of 60 kilograms, because we cannot forget that the skeleton originally had a mass of 10 kilograms before the treatment. The last part of this calculation is to estimate by how much the volume of Wolverine's bones increased after the adamantium was grafted to his skeleton. Now you can imagine that when this adamantium is grafted to the skeleton, it's going to create a layer of adamantium around all of his bones. Let's assume that this adamantium layer is quite thin. I'm going to make a quick assumption and say that the volume increased by just 5%. This would make the new volume of Wolverine's skeleton to be 0.00588 meter cubed. Using the mass of the adamantium bone skeleton and this volume, the density of adamantium bone can be estimated to be around 10,000 kilograms per meter cubed, which is roughly the same density as silver. This calculation I've just shown you can be seen as a back of the envelope calculation. I've made some assumptions, I've introduced the key parameters, but I have left out things that could influence the calculation. Nonetheless, I think the number that I've calculated is a good representation of the density of adamantium bone in Wolverine's body after the adamantium treatment. And finally, property number 5, is adamantium biocompatible? If something is biocompatible, it means that it can be put inside someone's body and it's not poisonous. In other words, it's non-toxic. Now, the early Marvel films featuring Wolverine seem to indicate that adamantium is non-toxic and that it is biocompatible. However, in the 2017 film Logan, it seems that adamantium is not biocompatible. In the film, Logan is depicted as being very close to 200 years old, and he had adamantium grafted to his skeleton in the past. Now, Wolverine, and one of his key powers is accelerated healing. And what has been happening over the course of his life is that the adamantium grafted to his body has been poisoning his body, but his body has been healing itself as quickly or as fast as the poisoning was taking place. But as he's gotten older, his healing factor starts to become less effective. And as a result, the adamantium starts to poison his body. And there you have it, 5 key properties about adamantium, ranging from whether or not it's biocompatible to a rough calculation on its density. And what about the material in the real world that's similar to adamantium in some ways? And I use that term very loosely. Well, the material I'm going to recommend is an alloy I mentioned earlier on. It's a titanium alloy, and it is titanium 6 aluminium 7 niobium. And that contains 6% aluminium and 7% niobium. That's the alloy that can be used to make artificial or replacement hips or replacement joints in the human body. That material is very strong, but more importantly for the human body, it's biocompatible, meaning that if you put it inside someone's body, it won't poison them. Thanks for watching this video on the properties of adamantium, and be sure to stay tuned for more videos on superheroes, Star Wars, and lots of other topics. And also subscribe to this channel and ring the bell for notifications on the latest videos. I've been Dr. Barry Fitzgerald, the superhero scientist, and until I see you next time, always think super.